Next, I'm really excited. We have Jordan Ellis, who, Jordan, if you don't know, is working at Google. He's also a contributor as well to ERC 8004. And so, Jordan, thank you so much. I appreciate you taking the time. Uh, Thank you for coming.
Yeah, thanks. Excited to be here. So yeah, I'm Jordan. I work at Google. I've been at Google for the last over 8 years on a couple different teams, the Google Cloud data centers and our ads billing pipelines. Currently, I'm on our Google Cloud Web3 team where we've collaborated with Coinbase to introduce x402 extension to our A2A protocol. And I've also worked with Marco on putting together the ERC 8004 contract. And so this is wanted to give kind of like a high level overview of what all of this means and how they all kind of work together. I'll be going through the A to A agent to agent protocol, AP2, the agent payments protocol, and the x402 A to A extension, and how all of these work together to facilitate secure transactions between multiple agent parties. Um, so to start, we'll kind of dive into A to A, what it is and like why it's needed. Let's say you wanted to build a travel agent that's an AI agent. You ideally want to connect that with two separate flight agents, maybe a hotel agent or an activity coordinator, to really fulfill your entire like travel agent's needs. Um, and you don't want to build all these individual agents, and there are already separate agents that exist remotely that you just want to connect with. So the world needs like a standard way for all of these agents to communicate and collaborate on tasks together. And that's where the A2A protocol comes in. This is an open standard designed to be the common language for these AI agents. Um, well, most frameworks like the agent developer ADK or LangChain or CrewAI all have these concepts of sub-agents or some multi-agent architecture system. A2A allows for these agents to communicate with remote third-party agents. So all of these agents could be using different stacks or agent frameworks, but still be able to collaborate and work on the same task. A2A facilitates this communication between a client agent and a remote or server agent. The client agent is responsible for formulating and communicating requests to its connected agents, while the remote agent's responsible for acting on those requests, trying to provide the correct information, or completing any kind of service that's requested of them. Um, it is a fully open source and open governance protocol. It was created in Google back in April of 2025 this year, and was donated to the Linux Foundation in June. Um, so we'll go over some of the core capabilities of this protocol. Its agents can dynamically discover and connect with each other, kind of like what Marco was talking about. There will be different sort of registries that support this, even some on-chain ones such as ERC 8004, where these agents will be discoverable. They can collaborate and standardize tasks and agree on them, that share content between each other, handle long-running processes and update each other while these processes are going on. And they do all this with an enterprise-grade security, and everything that's happening within each agent is opaque to the other one. So the protocol is only the bridge between them and doesn't need to expose the inner workings of each agent to each other. Um, A common question that we get frequently is A to A versus MCP and how they work together, if that, what that means. But MCP, which stands for Model Context Protocol, and A to A are pretty complementary protocols, and they're not competing. MCP is more about how an agent connects to tools, APIs, resources, prompts. It's a standardized way for agents to perform function calling or executing tasks on the behaviors on the user's behalf. The A to A protocol is how agents communicate between each other. Um, so A2A facilitates this dynamic communication between these independent agents and their peers. So you'll see in a sophisticated agent system, it's possible that agents use A2A and MCP as well. So here we're looking at an example of two different agents that are using maybe different LLMs. They're on different hosting services. They're connected to different MCP servers and have different skill sets. But they're able to like bridge all of that over A2A to work on tasks together. Um, so now we're going to kind of go into a little bit more about how A2A actually works, what the objects kind of look like, and the communication structure that happens between these agents. Um, so we've kind of gone over this. A to A facilitates communication between a client agent. So the client agent is the agent that your user is interacting with. And the client agent is responsible for identifying the remote agents it wants to connect to, handling the user's requests, and sending them to the correct connected remote agent. Something important to note is that any given agent can act as both as a client and a remote agent, depending on the context. And we'll walk through how we build a simple system where agent A needs agent B to do something. We'll go through kind of the core building blocks of A to see how that we enable this collaboration. In this case, agent A will be the client agent, and agent B is our remote agent or server agent. So finally, or first, how does agent A and find agent B and know what to do? Um, this is there can be multiple different ways on agent discovery and how like the endpoint is discovered, but once the endpoint is discovered, the agent B will present this agent. It publishes an agent card. Think of this as like its digital business card. It's a standard JSON file that's found at a well-known URL on the agent's domain. This card tells agent A everything that it needs to know to start a conversation with agent B, what agent B's kind of skills are, and what agent B is capable of doing. Um, Here's an example of what an agent card would look like. It has its name, the A2A service URL, and it explicitly lists its capabilities and skills. So agent A knows if it wants to engage in this with this agent to complete a task. Um, this card is served at a discoverable URI for the client agent to connect to, and the agent card can also present other information as well, such as like streaming capabilities or supported extensions, which we'll cover a little bit later when we cover the AP2 extension and the x402 extension. Um, so once agent A is connected with agent B, how does this communication actually flow now? Um, all of our methods and data structures for the agents are defined in the A2A spec. So both agents understand the requirements for these data types. Agents communicate using HTTPS over standard transports such as JSON RPC or gRPC. But the different transports can be used. Some of the standard A2A objects include this message object that we see being sent back here. Um, it has a role which indicates whether it's a message from the user, a message from another agent. It also has parts, which are the actual contents of the message being sent back and forth to the agent. Um, the parts can be plain text or a file or a structured JSON data object. When agent B receives this request, it's if it's a simple response, it might just respond with another message to the client agent to complete the request. Or if the request might take a little more time, it's would respond with a task ID. This is where a task object becomes pretty central to the A2A protocol. Um, it'll have a task ID and a status. The status of a task object's lifecycle would go from submitted to working to maybe input required or completed, or also failed in some cases. So when Agent A sends an initial request, Agent B quickly responds, says, okay, got it. I've kicked off this task like 1, 2, 3, and now it's working. So Agent A is aware of the task ID and the status of the task. Um, and Agent A can periodically poll or ask Agent B to get the status of that current task. Um, Once the task is completed, the agent B will update the task status to complete or failed and respond with an artifact object. This is an additional object that's created that is to be able to store and respond the completed task or any sort of object that might be have been requested by the agent or a final like receipt maybe from the remote working agent. Um, and to avoid like constantly polling the remote agents, if as the A2A protocol also supports server sent events, so as a streaming event where Agent B can say it supports streaming in its agent card, so Agent A now knows that. And once the initial task has been created, Agent A can just listen for updates on task status updates. Maybe it'll send a new event message saying the task is completed with a message, or a task artifact update event where the streamed event would be the actual finished artifact of that task. So it's much better user experience in this case where the agent, your client agent isn't constantly having to pull all of the possible remote agents that are working on different tasks for it and can just sit and listen for streamed updates. So how do these agents actually communicate? How do we figure out how do they understand these protocols? Well, there's an agent executor class, and this is a class that's provided in the AP2 SDK. We have a Python library for it that handles all the generic A2A protocol pieces and provides them to your underlying agent. So you essentially can create your agent using whatever agent framework, and then use this agent executor to handle the A2A protocol communications and connect it to your agent. The SDK handles all of the HTTP and JSON RPC conversions, along with the event management and focus on the agent processes and not actually the logic the agent itself is executing. Um, so kind of this is a suggested stack that one could use to create an agent that is able to be contacted via the A to A protocol. Um, you have an underlying agent framework, which could be anything, but in this example, we use ADK. This agent can connect to other services using MCP servers. Uh, this can be hosted on different hosting sites, but Vertex AI agent is one where we often use to host these. And then all of these will be wrapped within A to A to allow direct communication between all of these agents. So that kind of wraps up a quick run through on A2A. There's additional documentation and deep dives on other sections and a couple sample libraries as well to get it up and running and understand how you can build agents that are able to communicate using A2A. Now we're going to take a step further into A to A, into an extension, um, and to take a moment and kind of explain what an extension is. Um, Additionally, on top of the A2A spec, there can be custom specs written, known as extensions, which indicate additional skills or capabilities that an agent has, that can be presented in their agent card. So any connecting agents know that these specs and additional capabilities are supported. One of those is this AP2 extension, which stands for Agent Payment Protocol. It's a way for agents to securely transact between each other. So with A2A opening a world of like new agents to connect with and work together, the task start to become a little more complicated, and potentially requiring payments along the way for tasks to be completed, which kind of opens up um, a trust and security question that comes along with how can we make sure all of this is done securely. Um, so Imagine being able to describe what you want to an AI agent, and it can find and purchase that on your behalf, without having to do all of the research, and it's that your agent's able to make the best decision for you. But the kind of issue with payments now, our entire global payment infrastructure was built for humans and not autonomous agents. So today's payment systems assume that there's always a human in the loop directly clicking buy or supplying their card information. When an autonomous agent initiates a payment, it kind of breaks that assumption and raises like a lot of questions around the trust of the system. So how can we provide that a user gave an agent specific authority to make a particular purchase? And how can a merchant be sure that this agent request is accurate and true to what the user is wanting and not some hallucination from the agent? Um, and if there is fraud involved, who's accountable? At what point would the fraud originate, and um, who is liable in that situation? So this is why Google introduced the Agent Payment Protocol. It's an open source protocol as well, designed to create and secure trusted foundation for the future of AI-driven payments. It's compatible with existing standards such as A2A and MCP, and allows you to build up upon existing work to create a secure and reliable framework for this. Um, its kind of core concepts are openness and interoperability. We want to foster a competitive environment where everyone can innovate and build in this. Um, it's user controlled and privacy by design. We use verifiable intents and verifiable credentials, not inferred actions here. It's clear transaction. So we were trying to provide accountability and visibility into the entire chain of decisions that was made before a purchase was completed. And we want this to be global and future proof. So we want this to support classic pull payments like basic cards, but also additional forms of payment, such as maybe a crypto payment over x402, or any sort of additionally introduced payment rails. So how does AP2 achieve this? Here's kind of an example architecture where each actor has a specific job. Note that this is just like one of the setups that's possible, but the flows can be changed for the best use case. But in this flow, there's a shopping agent. This is the agent the AI user is talking to. It can be Gemini, it can understand requests, it can discover products and assemble carts. Um, there's a merchant endpoint. This is an agent or maybe even an MCP server that lives on the merchant side, and it's able to showcase products and negotiate cart prices and details with the shopping agent. There's then a credential provider. This is kind of a key point of security. It's a digital wallet in a sense that manages the user payment methods and securely handles the payment credentials. So that way your shopping agent is never actually touching private or personal information. And then there's the merchant payment processor, which handles retrieving the verified credential and payment credential from the payment processor. And all of this will be running on a NIC network or issuer. It could be different payment rails. The kind of core concepts here are a cart mandate, which it captures the user's kind of final explicit authorization for what it wants to purchase and at a specific price that was agreed to by the merchant. There's also an intent mandate for scenarios where a human might not be in the loop to authorize maybe the cart mandate, but the intent mandate is clear enough and has been verified by a user that the payment flow is allowed to proceed because the intent can be verified and trusted. And then finally, there's a payment mandate, which kind of ties these all together, and it creates a separate credential for the payment network to prove to the payment network that the users approve this payment and gives the payment network permission to release these funds to the merchant agent. So this is a little bit small, but to switch gears now to x402 extension as well, where the x402 could be used as a payment rail alongside of AP2 and an A2A ecosystem. Um, Kind of a quick flow is where a client agent would request a message, and the merchant agent now would respond with this x402 payment required response in the input required state for this task. Um, these are the x402 payment required objects that I believe Erik might have spoken about earlier. The client agent is able to iterate through the supported types here and select which wallet or what supported method is desired by the client here, and it's able to fulfill this request by creating a signed payment payload along with the task ID and sends that back to the merchant, where the merchant can take the task ID, verify that the signed payment payload is for the correct amount and is valid. The merchant agent will then process this request, and then using the x402 facilitator will post and settle that request, and then finally respond to the client agent with the settlement response. Taking another step further, these objects can be packaged and embedded inside of the AP2. So not only do you have assigned payment payloads, but these can be wrapped inside of intents, intent mandates and cart mandates. So there's a full flow of trust from as soon as the client agent indicates that it has a specific intent from a user, all the way through signing on behalf of the user's wallet to completing the final transaction and having the merchant settle it. So there's a auditability trail throughout this entire flow. I have a demo, but I think we might be at time, so I can share this out with the group as well, but it's kind of a quick flow showing a MetaMask wallet being used as the verifiable credential provider and signing the intents and mandates and settling the x402 transactions. There's some code samples for A to A, some more walkthrough, and then there's AP2 code samples as well, which will also link you to the x402 A to A repo to see how those objects work together.
Awesome. Thank you so much, Jordan. That was an amazing presentation. I'm really excited about everything that Google's doing in the agent space, and yeah, I think the tool suite is really great. A2A is just an amazing spec. Yeah, so I'm really excited to see that continue growing and get some more adoption there. So I appreciate your time, Jordan. If you guys want to ask any questions, or Jordan, I don't know if you can check out the Edge and Node Twitter. There might be some questions in the chat there that you can address later. But thank you so much, Jordan, and I appreciate you taking the time today. And we'll see you later for the fireside chat as well. So thank you.